The circuit shown is a series circuit with three resistors. R1 equals 4 ohms, R2 equals 12 ohms, and R3 equals 8 ohms. The circuit is supplied by 48-volt battery. Letter A, find the total resistance. Letter B, find the total current. C, calculate the voltage drop across each resistor. Verify your answer using Kirchhoff's voltage law. D, calculate the power absorbed by each resistor. E, calculate the power delivered by the battery. And letter F, find the voltage drop across each resistor using voltage divider theorem. For question A, the total resistance in series circuit is the sum of all the individual resistances. Therefore, RT is equal to R1 plus R2 plus R3. RT is equal to 4 ohms plus 12 ohms plus 8 ohms. So therefore, RT is equal to 24 ohms. For question B, we can find the total current using the Ohm's law formula. I is equal to E divided by RT. I is equal to 48 volts divided by 24 ohms. So therefore, I is equal to 2 amperes. For letter C, in series circuit, the current through each resistor is equal to the total current of the circuit. Therefore, V1 is equal to I times R1, which is equal to 2 amperes times 4 ohms, or 8 volts. For V2, V2 is equal to I times R2. V2 equals 2 amperes times 12 ohms. V2 equals 24 volts. And finally, V3 is equal to I times R3. V3 is equal to 2 amperes times 8 ohms. V3 equals 16 volts. Kirchhoff's voltage law states that in any loop, the sum of the voltage rises is equal to the sum of the voltage drops. Or in other words, the sum of the potential differences must be equal to 0. The voltage from the battery is a voltage rise, while the voltage across each resistors are voltage drops. Therefore, E is equal to V1 plus V2 plus V3, or E minus V1 minus V2 minus V3 equals 0. 48 volts minus 8 volts minus 24 volts minus 16 volts equals 0. For letter D, the power absorbed by each resistor can be calculated using the formula P is equal to I squared R. So therefore, P1 is equal to I squared R1. P1 is equal to 2 amperes squared times 4 ohms, or equal to 16 watts. P2 is equal to I squared R2, which is equal to 2 amperes squared times 12 ohms, or 48 watts. And for P3, which is equal to I squared R3, P3 will be equal to 2 amperes squared times 8 ohms, which is equal to 32 watts. For letter E, the power delivered by the battery can be calculated using the formula P is equal to E times I. P is equal to 48 volts times 2 amperes, or equal to 96 watts. And finally, for letter F, the formula for voltage drop Vx across any resistor Rx in any series circuit using the voltage divider theorem is equal to Vx equals Rx over Rt times E, where Vx is the voltage drop across any resistor, Rx is the resistor, Rt is the total resistance, and E is the voltage of the source. So therefore, for voltage drop V1 will be equal to R1 divided by Rt times E, or 4 ohms divided by 24 ohms times 48 volts, which is equal to 8 volts. For V2 will be equal to R2 divided by Rt times E, which is equal to 12 ohms divided by 24 ohms times 48 volts, which is equal to 24 volts. And finally, for V3 will be equal to R3 divided by Rt times E, which is equal to 8 ohms divided by 24 ohms times 48 volts, which will be equal to 16 volts. That's it for our video, and if you like it, please hit the subscribe button. and feel free to share it. Thank you very much and God bless.